Hi, welcome to Ace the SAT. I'm Laura March, and this video is going to just focus on circle questions on the SAT. And the first thing to know is in the reference information, which is at the start of each math section, they do give you the formula for area and circumference of a circle. So a lot of people mix these up, know that it is there, and they tell you the degrees in a circle is 360. So one formula they don't give you that's really, really important to know is the equation of a circle. X minus h squared plus y minus k squared is r squared. And it may help you to remember it to know that it's derived from the Pythagorean theorem, which is a squared plus b squared equals c squared. So it's something squared plus something squared equals r squared, if that helps. Number 11 is from test 10, section 3. A circle in the xy plane has center 5, 7 and radius 2, which of the following is an equation of the circle. So if you know your equation of a circle, this is an easier question. It's just x minus 5 squared plus y minus 7 squared is 4. The next question is a harder problem from test 5, which also implicates the equation of a circle. The equation above defines a circle in the xy plane. What are the coordinates of the center of the circle? So it's not in the form where it's be easy to see the center. So we have to figure out x minus what squared would give us x squared plus 20x. And it would have to actually be x plus 10 squared, because when you FOIL that, you'd get x squared plus 10x, which is plus 20x plus 100. So it would have to be x plus 10 squared. So h is negative 10. X minus negative 10 would give you x plus 10. So we know the answer is B. And you can see that negative 8 is right for the for k, because if you take half of 16, you'd have to have y plus 8 squared to end up with y squared plus 16y plus 64. Now let's look at number 9. This was from test 8, and it gives you the equation of a circle in the proper form. So we know then that the center is 6, negative 5, and the radius is 4. So we can sketch it. And here's the center, 6, negative 5, and radius 4. And it tells you point P is on the circle and has coordinates 10, negative 5. So we marked that. And we see P and the center have the same y coordinate, which means if I connect them, it's a horizontal line. And if I extend the diameter to Q, if PQ is the diameter of the circle, what are the coordinates of point Q? Well, the y coordinate would have to be negative 5. So we can eliminate B and C, and it's not 6, negative 5. That's the center of the circle. So it's 2, negative 5, which makes sense because if the center is at 6 and the radius is 4, the x coordinate of point Q is 2. Now let's look at number 29, which was from test number 7. A circle in the xy plane has equation x plus 3 squared plus y minus 1 squared equals 25. Which of the following does not lie in the interior of the circle? So knowing the equation for a circle, we know the center of the circle is negative 1, 3, and the radius is 5. So I'd go down 1 and down 4 and over 3 and 2. So my circle is something like that. Which does not lie in the center? Well, obviously the center of the circle, negative 3, 1 is in the center. I can see from my little drawing that the origin 0, 0 is in the center of the circle. So then the question is, what about point 3, 2? Is it here? Is it here? So let's look at it. Let's just say point 3, 2 is here and test really if it's in the center of the circle or not. And one way to do that is to see how far is 3, 2 from the center. I know my radius is 5. So if it's further than 5 away, it's outside the circle. So the best way to figure out that distance is to make a right triangle. And this leg is here to here is 3, and here is 3 is 6. And from 1 to 2, this leg is 1. And if I do 6 squared plus 1 squared, 36 plus 1 is 37. So the hypotenuse of this right triangle is rad 37, which is bigger than 5, bigger than rad 25. So 0.32 is outside the circle. Now let's look at number 20, which was from test 6. This is a grid-in. Points A and B lie on a circle. So I'm just gonna always give yourself a drawing. I just draw a circle and put points A and B on it, not sure where they are, and draw my center, and it says radius 1. So I'm just gonna mark a radius of 1. And the arc AB has length pi over 3. And they wanna know what fraction of the circumference is the length of arc B. So remember, the circumference formula is in the reference information, and it's 2 pi r. Radius is 1, so circumference is 2 pi. So they're asking what fraction of 2 pi is pi over 3? And I can write an equation, pi over 3 equals 2 pi times what fraction? X, for what fraction? I can divide both sides by pi, and I get 1 over 3 equals 2x. And to solve for x, I would multiply both sides by a half, and x is 1/6. And then number 34, the last question is from test 3. In a circle with center O, central angle AOB. So again, always give yourself a drawing, draw a circle, mark points A and B on the circle. And the central angle is 5 pi over 4 radians. The area of the sector formed by central angle AOB is what fraction of the area of the circle? So it would be helpful to convert this from 5 pi over 4 radians to degrees. And remember, pi equals 180 degrees. So I can change pi to 180 and divide by 4, and I get 225 degrees. So the central angle is 225 degrees. And the area of this sector is a fraction of the area of the whole circle, in the same proportion that this central angle here relates to the total angles in the circle, which is 360. So the area of the sector is what fraction of the area circle? It would be 225 over 360, which equals 0.625. So if you know the equation of a circle, you can do a lot of these circle problems, and that's it for circles.